All right, you guys, I am starting off with question number 12. I know the schedule's off a little bit. Should have ended with 12, but we're going to start with 12 on this one. And then we will go from 12 all the way to number 16 on this one. Okay, so here we go. Start with number 12. So to find the exterior angle measure, we are going to use the exterior angle formula, which says, the theorem, which says, if you take anything on the outside out here of a triangle, it is equal to these two sides added together. They're the two non-adjacent sides, the ones that are not touching the angle itself. So in this case, the x is going to equal the 74 plus the 47. So if I do that, I get that's 121 when I add those together. Now another option you can do is that the three angles in a triangle have to add up to 180. So you go 74, plus 47 equals 121. If I take 180 minus 121, I wind up getting 59, right? So that means that this angle right here, this 59 would go right here to this angle. This makes a straight line. So we take the 180, we subtract the 59, and I still get 121. So either way, our answer is going to be 121, okay? All right, next question. Oh, get my thing right here. This is going to be question number 13. Now, this is a really big page, so I'm going to kind of use the information. I'll have to slide my paper up and down so you guys will see. So the question says, use the following figure to determine the motion rule that describes the reflection from quadrilateral ABCD to quadrilateral LMNP, and then they want you to put the answer. So here are my answer choices, so I'm going to pick one of these. So what I'm going to do is I'm going to pick, and notice that I've got A right here has to pair up with L. So I'm going from A to L, okay? So I want to see what my movement is from A to L. So I'm going to come down here, and I'm going to tell you that point A is located right here at +1, -1. Okay, that's where point A is, right? And then we have point B, and I'm going to go through and do all of those. So I'm going to do all of that information. You got +1, -1, and I'm going to write it over here off to the side, and then I'll come back and we'll look at our measurements here, okay? So if I put over here, I said A was located at 1, -1, right? We've got B is located at 2, -1. We've got C is located at 3, -4. And D is located at 1, -4. And I'm moving all of those are getting rotated, reflected, and they want you to land. A has to pair up with L, B has to pair up with M, C with N, and D with P. Well, L is located at -1, -1. M is located at -2, -1. N is located at -3, -4, and P is located at -1, -4. And if you'll notice in the movement, the only thing that took place was all of my Y's stayed exactly the same. So when I started over here with X, Y, right, and I moved, all of my Y's stayed the same. They did not change, all of those. But my X's all went to the opposite of what they were before. So that is the rule that has been applied. Now, that is actually the rule is reflecting, right, over the y-axis. Now, they didn't ask us that. They asked us to pick which one of these up here it represents. And remember, down here we said my x changed, my y stayed the same. So I need where my x stayed, and my x changed and my y stayed the same. So this would be my answer. Okay? Next question. Question number 14. Okay? Question number 14. All right. So for question number 14, right up here we have, says rotate the given shape 90 degrees counterclockwise around the origin. Now, I don't have the shape is not on the picture right here, okay? But I am going to give you the rules for the 90 degrees counterclockwise, and then I'm going to write down the coordinates that were on the actual picture of the shape, okay? So we're rotating the given shape 90 degrees counterclockwise. So 90 degrees counterclockwise. You'll remember that rule states that you take X, Y, we whoop, and we change the first one. So we're going to change them the X is going to go to the back, the Y is going to come to the front, and we're going to change the first one. So we're going to do that with all of our coordinates, okay? So whoop, change the first. Just a little side info, don't forget 270 counterclockwise, oops, I should have W. We whoop and we change the second, right? But we're doing this one, right? So we're doing the 90 counterclockwise. So if you looked at your picture, you've got coordinates A, B, C, and D, right? Coordinates for A are located at 2, 2. B is located at 8, 1. Okay? Sorry, is that read my thing here? Yeah, I'm sorry. Oh, sorry, that's a 4, not an 8. I'm sorry about that. Sorry about that. It's located at 4, 1. C is located at 6, 5, and D is located at 3, 5. And so now we're going to apply our rules. We're going to put our primes here, and we're going to apply our rules. So we're going to switch them. So the 2 and the 2 are going to switch places, and we're going to change the sign of the first one. Okay? And then our B's, we're going to switch places. 1 and 4, we're going to change the sign of the first one. And then our 6 and 5, we're going to change places. 5, 6, we're going to change the sign of the first one. And then D, our 5 and 3 and 5, we're going to change places. That's going to be 5, 3, and we're going to change the sign of the first one. Okay? And then we would just take these and we would actually graph those onto the actual picture itself. Okay? So that was our number 14. Okay? The next one up is going to be number 15. Okay? So here's number 15. Number 15 says, I'll read the top and then we'll do the work. Lily wants to define a transformation or a series of transformations using only rotations, reflections, and translations to solve and to make it so that figure A takes figure A so that it lands onto figure B. Okay? So there's a few things going on here. First of all, if it's going to land onto the figure, the two figures have to be exactly the same. So we first want to double check that and make sure that's the case. So if I look up here, this goes 1, 2, 3, 4, 5. So this is 5 units long, okay? If I count down here, 1, 2, 3, 4, this is 4 units long. This one is 1, 2, 3, 4, 5, 6, 7. So this is 7 units long. And then this one, I'll check and see in a minute if I need to check that one, because that would be the diagonal there. So then if I check this one up here, it goes 1, 2, 3, 4, 5, 6. This is 7 units long. This one goes 1, 2, 3. That's 3 units long. And then these two are both diagonal. They're not going to be flat surfaces. They're not going to be parallel. They're not going to be, horizontal or vertical. What that tells me is that these are not the same shapes. And if they're not the same shapes, then they cannot rotate, reflect, or do anything to land onto each other. Now you could rotate it, like you could reflect it, over this way or rotate it around, and it could get close, but it's not going to land directly on it because they're not exactly the same shape. So our answer right here is D, because they are not congruent to each other. So they will not land on each other. Okay? All right. Next question is going to be question number 16, and this is our last one for this group. Okay? So here goes question number 16. Okay? For question number 16, says JKL is reflected across the x-axis and translated right 1 and down 3. What are the coordinates of the final image of point K under this composition of transformations? So we got two things going on here. So first we're going to start, oops, sorry about that. My thing right here, sorry about that. We're going to start off with point K. This is my original point. We have two things. It's being reflected across the x-axis. So movement number 1, so this is our first movement right here, is we're going to reflect across the x-axis. Okay? And then movement number 2 over here, it says we're going to go, it's a translation, and we're going to go right 1, so that's a positive 1, and we're going to go down 3. So down 3, okay? So we need to apply the rules to our coordinates. So we're going to start off with K. We're going to find out where K is currently. So currently K is located. Now, caution on this, you'll notice these are counting by 2s. So I go 2, 4, so that's right 4, and then up 2, 4, and over 4, okay? So now, our rule for reflecting across the x-axis, you'll remember, is we keep the x and we change the y. That is the rule for reflecting across the x-axis. So when I do that to K, which is 4, 4, I'm going to keep x, I'm going to change y. That becomes a 4 and a negative 4, okay? Now I'm going to apply my translation. So my second movement, my translation, right? Sorry, two primes, two little dots. I put a number 2 instead of putting the 2 lines. Is I'm going to increase my x value by 1. So that's going to be a 5. And I'm going to decrease my y value by 3 because I'm going to go down 3. I was at -4, go down 3 more. That puts me at -7. My final location for k is at 5, -7. And that is actually answer letter C. Okay? All right. I'll see you on the next one.